Solve the system using substitution. We first need to look to see if we have an x equals or a y equals. I see x equals right here. It is equal to 2y minus 5. I'm going to note that this is what x is equal to. I'm going to draw an arrow from what I've circled to the variable x in the other equation. If x is equal to 2y minus 5, then we could take 2y minus 5 and plug it in place of x in the other equation. So instead of having 3x minus y is equal to negative 10, we're now going to have 3 times, instead of x, I'm changing x to 2y minus 5. So 3x becomes 3 times 2y minus 5, and then I bring everything else down. Negative y equals negative 10. We have a y and a y. We have successfully eliminated x's from the equation, so now we can solve for y, and we will get an answer. So 3 times 2y is 6y. 3 times negative 5 is negative 15, and we bring everything else down. Negative y equals negative 10. I'm now going to combine like terms. I have a 6y as a variable term, negative 15 is a constant, negative y is a variable term, and negative 10 as a constant. So I want to get my variable terms together and get rid of the constant to the other side. 6y minus 15 equals negative 10. Grouping up my variable terms, if I have 6 y's and I give one away, I am left with 5 y's. Minus 15 equals negative 10. I have a variable term. Let's get rid of the constant. If I owe 15, I'll cancel that out by the inverse, which is positive 15. What I do to the left side, I have to do to the right side. So moving across the equal sign, I will add 15 to the right. 15 take away 15 is 0. So on the left side, I have 5y. Bring down our equal sign, and we are left with 5. Let's divide both sides by the coefficient of y, which is 5. So y equals 1. Now that we know what y is equal to, we can go back to our original equations and plug 1 in place of a y to find what x is equal to. It works with either equation. So if I said x is equal to 2y minus 5, well, y is 1, so it's x is equal to 2 times 1 minus 5. 2 times 1 is 2, minus 5, this is equal to x, so x is equal to negative 3. This means the solution, the point where the lines intersect, is negative 3, 1. We're not done yet, however, because we need to verify our answer. To verify, we're going to take our x, y answer and plug it in to both of the original equations to make sure that they balance, that they work. So, x is equal to 2y minus 5. I'm going to plug negative 3 in place of x. Is equal to 2 times y becomes 1 minus 5. Negative 3 is equal to 2 times 1 is 2 minus 5. 2 take away 5 is negative 3. Does negative 3 equal 3? Yes. Our solution of negative 3, 1 works for the first equation. Because our solution of negative 3, 1 works for our first equation, we now need to check the second equation. If we have 3x minus y is equal to negative 10, we're going to take our x value of negative 3 and plug it in place. So instead of 3 times x, it's 3 times negative 3 minus a y, which is 1. That's equal to negative 10, maybe. 3 times negative 3 is negative 9, and we bring everything else down. Negative 9 minus 1 is negative 10, and that's equal to negative 10. Does negative 10 equal negative 10? Yes, it does, which means having our solution of negative 3, 1 work in both of the original equations, we know that we have verified our answer and the two lines that this system is true at negative 3, 1.